Hello guys, welcome back to my channel. Today we are going to solve the equation for the elastic collision in one dimension. So let's read the question. Prove that in an elastic collision, two bodies, the relative velocity of approach before collision is equal to the relative velocity of separation after collision. For reference, let's draw a diagram. First body with the mass m1 and velocity m2, and second body B with the mass m2 and velocity u2. Both after collision, m1 and m2 equal to the object A will be equal to velocity v1 and mass m1 after collision, and the object B will be m2 and v2. So for this equation we have to write an introduction for the equation. So let's begin with the introduction. So we have to write this introduction in our own words. So as we can see over here, so let's write, let's assume two objects moving with a velocity of u1 and u2, and mass m1 and m2. The velocity after collision will be v1 and v2, and mass will remain the same. So let's find the momentum for the above equation. Momentum before collision equal to momentum after collision. The momentum before collision was momentum A plus momentum B equal to momentum A dash plus momentum B dash. So momentum of A block will be equal to, so let's first see what is the formula of momentum. Formula of momentum is equal to P is equal to mv, right? This is the formula of momentum. We have to arrange this object's mass and velocity in this formula. So it will become of A object, it will become m1 and u1, plus of B object it will become m2 u2, equal to, after collision of A dash object it will become m1 v1, plus of B object it will become m2 v2. So what we have to do next, we have to bring the v1 and u1 on one side and v2 and u2 on the other side. So m1, then this will become u1, plus we have to, no, it will become minus, we have to bring this m1 v1 this side, so it will become m1 v1 equal to, over here m2 u2, minus we have to bring m2 u2 on that side, so it will become m2 u2. So now we have to take m as common over here, m1 as common over here, so u1 minus v1, and over here m, also m we have to take as common, so here v2 minus u2. This is our first equation. So here momentum before collision and momentum after collision is conserved. So now let's find the kinetic energy. Is it conserved before and after? Let's see. So kinetic energy before equal to kinetic energy after. So what is the formula of kinetic energy? Kinetic energy is equal to half mv square. So we have to put the values of the objects in this manner. So it will become Ka plus Kb equal to Ka dash plus Kb dash. So kinetic energy of object A will be half m1 u1 square, plus kinetic energy of object B will be equal to half m2 u2 square, and the kinetic energy after collision of block A will be equal to half m1 v1 square, plus the kinetic energy of block B after collision will be equal to half m2 v2 square. So now we have to bring the values of m1 on one side and m2 on another side. So we have half m1 u1 square minus, we have to bring this on that side, so half m1 v1 square equal to half m2 v2 square minus half m2 u2 square. So over here now we can take half and m1 as common, so it will become u1 minus v1 the whole square. which is also equal to half m2 v2 v2 minus u2 whole square. So half and half cancels out. So now it will become half m1. We can write u1 minus v1 square as u1 minus v1 u1 plus v1 equal to m2. Over here v2 minus u2 we can write it as half gas cancels over here. Okay, half is not there, so we can write it as v2 minus u2 v2 plus u2. So now this is our equation 2. So now we have to divide equation 2 by 1. So it will become m u1 minus v1 u1 plus wait now so it will become u1 plus v1 upon m1 u1 minus v1, which is also equal to m2 v2 minus u2 v2 plus u2 upon m2 v2 minus u2. So now we have to cancel out the things. So m1 and m1 will get cancelled out, m2 and m2 will get cancelled out. Over here this and this will be get cancelled out, this and this will be also getting cancelled out. So we are left with u1 plus v1 equal to v2 plus u2. So now we have to take the values of u on this side and values of v on that side. So it will become u1 plus u2. No, it will become u1 minus u2 equal to v2 minus v1. So the relative velocity of approach will be equal to relative velocity of separation. So here we have conserved the momentum and velocity of this equation. Thank you.